All right, I had a few requests to do the last two problems of the last module, and I already completed it, but I will do a similar problem to show you how it's done. Kids are home upstairs, and so there might be some interruptions, but that's okay. We'll get through it. All right, so here it is. Module 8, Lesson 4. Let's do a similar question. Assume samples are random and independent. Populations are normally distributed, and the population variances are equal. Okay, so all of the conditions have been met. The table available shows the prices for sample of automobile batteries. Prices are classified according to battery type. At the significance level of 0.01, is there enough evidence to conclude that at least one battery price is different? So there's the claim that at least one battery price is different. Okay, first, null hypothesis. Null hypothesis always has to have statements of equality. So in this case, we assume all three prices are equal. And the alternative is that at least one is different. So let's see what we're talking about. Here are the battery prices. If we click the box, there's the battery prices. I think it's battery prices, right? Yeah, battery prices for different size batteries. Okay, and we can upload those in a StatCrunch. All right, so far so good. And so remember that the claim was that there is a difference between at least one of them. That was the alternative hypothesis. All right, so let's make sure that that's right. We're good to go there. Next. All right, so the critical values, that's like the borderline that separates where we reject the null hypothesis or fail to reject the null hypothesis. So remember, the rejection region is always out on the extreme. So it's really far away. So it has to be greater than the, the F value has to be greater than the critical value to reject. Okay, so we'll find the F value here in a little bit. This is just the critical value. That's our borderline. In order to reject, our F value has to be greater than that, has to be extreme. So where is this critical value? Well, the critical value comes from our degrees of freedom. And with F statistics, we have to go to our F calculator. So the F calculator is in StatCrunch. If I can get to StatCrunch back here again. Here's StatCrunch. If you go to calculators, and go down to the F calculator, you can find where that critical value is. And the critical value is where the point at which we only have 1% of the area in our curve is out on the right-hand tail. So what is our degrees of freedom for our numerator? Well, what we do there is we take the number of groups minus 1. There was 3 groups. I'll let you see here. 3 groups. 3 groups minus 1 is 2. And how about the denominator's degrees of freedom? Well, that is the total number of batteries sampled minus the number of groups. So there are 2, 4, 5, 10, 15. 15 minus 3 groups, that's 12. So 12 degrees of freedom for the denominator. So again, 3 groups minus 1 is 2. 15 batteries sampled minus 3 groups is 12. And we want 1% in our tail. There's that. And that needs to be 1% in our tail to the right. So I had to put that as a greater than symbol. I don't know if you saw that, but I switched this to a greater than symbol. I wanted to be sure that that's 1% out on the tail to the right. And that will give me my critical value, 6.93. 2 places to the right, 6.93. 6.93. Okay, that's the critical value. Anything that is greater than 6.93 for my F statistic, I reject the null hypothesis. So here's my F statistic. How do I find my F statistic? Is I have to run an Anova test. So back to StatCrunch where we have the data loaded up. Close that out and let's run an Anova test. Stat, Anova, this is a one-way Anova. Select all of the columns. Hit compute, and that will give me my F statistic right there. F statistic 3.44. 3.44. Okay, that's it. So now I can compare my F statistic to my critical value. It is not greater. Remember, it has to be more extreme. It has to be greater than my critical value. It is not. So I do not reject the null hypothesis. Fail to reject the null hypothesis because it's not in the rejection region. So if I fail to reject the null hypothesis, that means that I accept the null hypothesis, or at least fail to reject it. But we say, okay, well, that's good to go. We're good there, and we're not so good here. There's not enough evidence for the claim. There is not, this is a statement about the claim. See, the claim. There's not enough evidence at the 1% significance level to support the claim that at least one battery price is different from the other. There's not enough evidence to support the claim. Okay. So that's good to go on number 4. Let's quickly go to number 5. We'll do a similar question here on number 5. Module 8, Lesson 4, number 5. The table shows the weights of sample vacuum cleaners. The weights are classified according to cleaner type. At the 1% significance level, or 0.01, can you conclude that at least one vacuum cleaner's weight is different? Okay, so here comes the vacuum weights. We got 3 different types of vacuums. A total of 1, 2, 3, 4, 5, 6. 6 times 3, 18 total vacuums, 3 types of vacuums. We want to see if the weights of these vacuum cleaners are significantly different. We know they're different, but are they significantly different? Remember, the null hypothesis assumes that they're equal, but the alternative says that at least one is different. That's why I choose this one. Assume that they're equal, and then the alternative is that at least one is different. So I'll go ahead and check that. The F statistic, that's not the critical value. They're just asking for the F statistic. So I can upload that in a StatCrunch and get the F statistic. Remember where we find the F statistic is in the Anova. So we run an Anova test. Anova, one way. Select all 3 columns and compute, and that's going to give you your F statistic. So my F statistic is 4.68 to 2 decimal places, 4.68. Sorry, 9.68. 9.68 gets me my F statistic. And then they're going to ask you for the p-value. The p-value is the probability that you will observe a sample like this if the null hypothesis is true. Remember, the null hypothesis is that they're equal. So if they're equal, how likely is it that if the weights of all of these vacuum cleaners are equal, what's the probability that you're going to see data like this? Well, that's what the F statistic is about to, that's what the p-value is about to show us, the probability that you will observe something like we have observed if the weights are the same. And you can see the probability is very small, 0.002, less than 1% probability. 0.002 probability. Okay, so that is the p-value. Okay, so what can we do is we can say that we can use the p-value. And remember, the p-value can be compared with the alpha value. If the p-value is less than alpha, well, what do? We reject the null hypothesis. We reject the null hypothesis. So it's up to these two. This guy says, reject the null hypothesis. There's enough evidence to conclude that the mean weights vary across the vacuum cleaners. Yes. Why? Because that's the alternative claim. The alternative claim says that they vary. So if we reject the null hypothesis, then we accept the fact that they vary based on the alternative claim. And that's that. Okay, hope that helps.